Okay, today we're here and we're going to learn about linear motion. Linear motion is motion that takes place in a straight line, hence the word linear. Now the first thing you need to know about linear motion is that it deals with position. Position is simply where an object is located and you compare it against a frame of reference or a background. Okay? It's the only way that you can tell that something is moved is to take and to compare it from or to something else. Now distance is simply a change in position. You know how far something has moved if you can look at the beginning point and the end point. Displacement, on the other hand, displacement is how far and in what direction an object has moved, and it's really important that you make sure that you look at that from the starting point. Okay, it has to be measured from the starting point, not the end point, but the starting point. Speed. There are three different types of speeds that we're going to talk about. Remember, speed is just how fast we're going. Okay, so the amount of distance that has been moved in a given time. But instantaneous speed is how fast we're going at a certain time. So if you wanted to take a look at that, and if you were driving along, let's say we're moving from here and we're driving to Pella, and you wanted to know your instantaneous speed, like when you see a police officer, everybody automatically starts to slow down and looks right at their speedometer. That's your instantaneous speed, and the police officer would give you a speeding ticket based on your instantaneous speed. Okay. Now constant speed is an unchanging variable of speed over time. So there's no speeding up or slowing down. It's like if you're on cruise control. Sorry for Cohen. He's trying to add to the presentation here. Average speed is an average of how fast you're going over a given amount of time. And we'll do a little bit more work with that in a minute here. So speed is rate of change in position in a given amount of time. The equation that you need to know is that speed equals distance divided by time. And units for speed can be meters per second, kilometers per hour, miles per hour, feet per second. Those are the most common ones. Now please, there's one thing I want to say about this. Notice how these are being written. We don't use the MI or the MPH like you'll see on your car. You'll see the MPH. We don't use that in physics. We do the MI/H. And if you want to do it totally nice and neat so you know exactly what that means, you could take and write that as MI and then hours underneath. So you're using a vertical line instead of the slash there. Okay? Okay, now it's one thing that you need to remember about this speed equals distance divided by time equation. This you can only use when there is no acceleration. And we're going to take and we're going to define acceleration here in a few slides, but for now just put down that speed equals distance divided by time can only be utilized when there is no acceleration. Now velocity, you took and you did your little pre-activity here, and it talked about velocity, and I hope that through that activity you were able to determine that velocity is speed in a given direction. It is a vector quantity. Now vector quantities are super important. We're going to use them all year long. Vector quantities have two parts to them. So two parts to a vector quantity: magnitude, which would be like your speed, so 55 miles an hour, and again your given direction would be like northeast. To calculate velocity, you take the displacement and you divide that by the time. And again, there are some labels here, and you'll notice these are only different from the speed labels by the direction that takes place. Okay, so like miles per hour east, kilometers per hour south, feet per second up. Sometimes we don't have a specific direction, so sometimes you have to say meters per second perpendicular or with the horizon or things like that. Now average velocity can take, and the average velocity, this bar right here stands for average, is taken and to calculate average velocity, you take the final velocity and you add the initial velocity to it, and then you take and you divide that total by 2. So it's just like taking an average of two things, which kind of makes sense. You have two different speeds, you divide it by 2, it makes sense to get the average. For example, what's the average speed of a car that's originally going 15 meters per second and then speeds up to 55 meters per second? So we want to find the average velocity. All right, here we go. We are originally going 15 meters per second, so that would be my initial velocity. I'm going to take my initial velocity, I'm going to add my final velocity, and then I'm going to divide by 2. So if we take and we do the math here, help me out, I don't have a calculator, 15 plus 55 would be 70, and I'm dividing that by 2, so my average speed here would be 35 meters per second. Now, moving on to acceleration. Acceleration is the rate of change in velocity. So again, it's not for speed, it is velocity. It is a vector quantity. Since velocity is a vector quantity, your acceleration has to be a vector quantity. And therefore, whenever there's a change in direction, there's an acceleration. The acceleration can be positive or negative. And what do we call that negative acceleration? The equation to calculate acceleration is delta V over t. Remember in the tutorial yesterday, the little activity that we did, the pre-learning, that delta, that triangle stands for delta, and it just means change in. They also had a delta t here because you have to have a change in time in order to have a change in velocity. So, but that's kind of understood with physicists. So we take then, to get any change in, you always take the final minus the initial, and you divide that by the time here. Okay, so again, to do proper order of operations, we would take this VF minus VI, we would calculate that, and then we would take and divide by t. Now units for acceleration are meters per second squared, feet per second squared, kilometers per hour squared, and miles per hour squared. These are all units. If you notice, the time value is squared. And the reason that that happens is because we're taking something like meters per second and we're dividing it by time, which is dividing it by seconds. So we could put seconds over 1. Now remember, whenever you take and you divide something, you can also multiply by the reciprocal. So this then is equal to meters per second times 1 over second. And when you do that, you multiply across the top, you divide by the bottom, and seconds times seconds is seconds squared. Okay, for an example, we have the velocity of a car, which increases from 0 to 45 meters per second east. What does that east do? Well, all that does is help to tell us that it is actually a velocity, and it does this in 5.2 seconds. They want to know what is its acceleration. When I'm faced with a problem like this, I like to make a list of all of the information that I know or label it. Sometimes you can label it right in the problem. Sometimes you need to take and write out a list. So we have 0 here. 0 would be my initial speed. So I'm going to label that VI. And then we're increasing to 45 meters per second. So that would be my final velocity. That's my VF. I have 5.2 seconds. 5.2 seconds is a time. That's pretty obvious. Okay, we can usually pick out the time. And then they want to know acceleration. So when we solve these problems, you're first going to give me your equation. So acceleration equals VF minus VI all over t. Okay, so if we take and we plug in our numbers, we have 45 minus 0, and we divide that by 5.2. And again, remember, this up here is going to be meters per second. This is seconds, so we have our meters per second divided by our seconds. And if you take and you do the math here, you're going to go ahead and you're going to get an answer, and that would be in meters per second squared. And the direction on this is going to be important. It is an acceleration, and the acceleration would be in the direction of the velocity, so it would be east. And I'm going to let you get your calculators out and calculate that on your own. So example 2. They want to know what is the acceleration of an airplane cruising at a constant speed of 650 miles per hour. So let's take a look at this. Now we have something that's cruising along. Key words here are constant speed. Whenever we have a constant speed, do we have an actual change in velocity? Are we moving from one velocity to another? No, we're not. So if you take and you look at our equation here, our equation is A equals VF minus VI all over T. Our final velocity here is 650. Our initial velocity is 650. So if we divide that by time, we've got 0 divided by time, and 0 divided by anything is going to give us 0. So it's really important to make sure that you remember whenever you have a constant speed, that means that your acceleration is always going to be equal to 0. So therefore, an object that's moving with constant speed has 0 acceleration, but an object with 0 velocity can have an acceleration. I'm going to leave this up to you to think about this and to figure out how you could have an acceleration with a 0 velocity.